Good morning, dear students. Now we are going to see the another one lesson, that is organic chemistry. It is in the second volume and unit 11. And the topic is hydroxy compounds and ethers. This we already studied in the previous class itself. The continuation only now we are going to see. Okay. So you take your book and get ready with the book hydroxy compounds in second volume. Clear? Okay. Shall we go to the lesson? Yes. Previously we studied the nomenclature of the alcohol as well as the hydroxy derivatives, that is alcohols are called as the hydroxy derivatives, and we studied the monohydric alcohol, dihydric alcohol and trihydric alcohol, and those properties and preparations we finished, and under which now we are going to see the properties of glycol. That is nothing but the reaction of glycol. Glycol is nothing but it is a dihydroxy alcohol. That means which is having two hydroxyl group. Okay. Are you ready? Yes. Reaction of glycol. Ethylene glycol contains two primary alcoholic group and it exhibits the usual reactions of hydroxyl group like other primary alcohols. It reacts with the metallic sodium to form monosodium glycolate and disodium glycolate. The hydroxyl groups can be converted to the halide groups by treating glycol with halic acid or with the phosphorus trichloride, phosphorus pentachloride or sulfonyl chloride. When ethylene glycol is treated with HI, that is hydroiodic acid, or phosphorus in the presence of iodine, you will get 1,2-diiodoethane. And then it is decomposes to give ethene, which is having the double bond. That is CH2OH, CH2OH. In the presence of phosphorus and iodine, you will get CH2I, CH2I. And further it is decomposes to give CH2 double bond CH2, which is ethene. On heating this on heating this one with the concentrated nitric acid and with sulfuric acid, that is called as nitrating agent, there those two H group are removed and NO2 is substituted there. That is CH2O NO2, CH2O NO2. That is called as 1,2-dinitroxyethene. It is otherwise called as dinitroglycol. Next is dehydration. Dehydration means, you know, it is the removal of water. Ethylene glycol undergoes dehydration reaction under different conditions, and under the different conditions it is giving the different products also. First, if it is heated to 773 Kelvin, one of the water molecule is removed and you will get only the oxygen in that place. So that is CH2O, CH2, that is called as oxyrane, and also it is called as epoxyethene. Next, if it is treated with sulfuric acid or anhydrazine chloride under pressure in a sealed tube, it gives acetaldehyde. First, it is giving one vinyl alcohol, which on tautomerization, you will get CH3CHO, that is called as ethanol. Al, that is aldehyde. Next, if it is distilled with the concentrated sulfuric acid, glycol forms dioxane. That is both the ends, there are two molecules are taking part in that reaction. Both the ends, one water molecule is removed and you will get CH2CH2O, CH2CH2O, like a cyclic form, that is called as 1,4-dioxane. Next is oxidation. Oxidation of glycol gives a variety of products depending on the nature of the oxidizing agent and other reaction conditions. When nitric acid or alkaline potassium permanganate, that is acts as an oxidizing agent, the products are first the primary alcohol is converted to aldehyde and then it is converted to acid one by one. So first you will get the glycolic aldehyde and then glycolic acid, then glyoxalic acid, and the final product is oxalic acid. Like the same, if it is undergoes both the primary alcohols undergoes oxidation, and you will get two aldehyde group, that is called as ethane 1,2-diol, that is further converted to glyoxylic acid, and then finally it is converted to oxalic acid. Next is oxidation of glycol with periodic acid. Ethylene glycol on treatment with periodic acid, it gives formaldehyde, 2 molecules of formaldehyde. This reaction is the selective for the vicinal 1,2-diol, and it proceeds through a cyclic periodate ester intermediate. That is, this glycol, if it is treated with HiO4, that is periodic acid, and first you will get a cyclic ester, which on further you will get the 2 molecules of HCHO, that is nothing but formaldehyde. Okay. Next, reaction of glycerol. Glycerol, that you know, it is the trihydroxy alcohol, that means which is having 3 hydroxyl group. Nitration. First, nitration. Nitration, you know, the nitrating agents of sulfuric acid and nitric acid. So, if it is treated with sulfuric acid and nitric acid, it undergoes the reaction that is called nitration. Here also the same thing happens. The H and H in all the alcoholic group is removed and NO2 is substituted in that place. So, you will get CH2O, NO2, CHO, NO2 and CHO, NO2, CH2O, NO2. That is called as 1,2,3 trinitroxypropane. Next is dehydration, that already I told you. Dehydration means removal of water. When glycerol is heated with dehydrating agent, that is sulfuric acid and KHSO4, those are all called the dehydrating agent. If it is reacted with those dehydrating agent, you will get the acrolein, that is also called as proptoenol, that is it is having a double bond as well as an aldehyde group. Next, oxidation. Glycerol can give rise to a variety of oxidation products depending upon the nature of the oxidizing agent. For the oxidation, oxidation of glycerol with the dilute nitric acid gives glyceric acid and tartronic acid, and oxidation of glycerol with the concentrated nitric acid gives mainly glyceric acid, and oxidation of glycerol with bismuth nitrate gives a meso-oxalic acid. Oxidation of glycerol with bromine water or NaOBr or Fenton's reagent, that is nothing but ferrous sulfate and hydrogen peroxide, gives a mixture of glyceraldehyde and dihydroxyacetone. And this mixture, that is glyceraldehyde and dihydroxyacetone, that mixture is called as glycerose. On oxidation with periodic acid, that is HiO4 or lead tetraacetate, LTA, it gives formaldehyde as well as formic acid. And acidified KMnO4 oxidizes the glycerol into oxalic acid. And those reactions only given here. In this one, you must know the CH2OH group. First, it is converted to CHO and then it is converted to COOH. Like the same, one primary alcohol and the last primary alcohol is converted. And at the center, you have the secondary alcohol, that is CHOH. If that undergoes oxidation, you will get the ketone group, that is C double bond O, and which again undergoes the oxidation. Now finally, you will get the oxalic acid. Next is uses of alcohols. Uses of methanol. Methanol is used as a solvent for paints, varnishes, shellac, gums, cement, etc. And in the manufacture of dyes, drugs, perfumes, and formaldehyde. Then uses of ethanol, the second member. It is used in the preparation of paints and varnishes, organic compounds like ether, chloroform, iodoform, etc. Then it is used in the preparation of dyes and transparent soaps. As a substituent for petrol, it is used as a power alcohol. It is used as a fuel for aeroplanes. And also it is used as a preservative for the biological specimens. Next, uses of ethylene glycol, that is dihydroxy alcohol. Ethylene glycol is used as an antifreeze in the automobile radiator. And its dinitrate, that is used in the explosive with the name TNG, that is trinitroglycerol. Next is uses of glycerol. Glycerol is used as a sweetening agent in the confectionery as well as in beverages. It is used in the manufacture of cosmetics and transparent soaps, and also it is used in making printing inks, stamped ink, and lubricant for watches and clocks. It is used in the manufacture of explosive like dynamite and cordite by mixing it with the china clay. Next, we are going to see the acidity of alcohols. According to the Bronston theory, an acid is defined as a proton donor, and the acid strength is tendency to give up a proton. Alcohols are weakly acidic and their acidity is comparable with water. Except methanol, all other alcohols are weaker than water. The Ka value for water is 1.8 into 10 power minus 16, whereas for alcohol, the Ka value is in the order of 10 power minus 18 to 10 power minus 16. Alcohols react with active metals like sodium, aluminum. It forms the corresponding alkoxide with the liberation of hydrogen. That is, hydrogen atom in that one is removed and substituted by the sodium group, that is Na. And the equation is given here as C2H5OH gives plus Na gives 2C2H5ONa plus H2. This reaction explains the nature of the alcohols. Next is comparison of primary, secondary and tertiary alcohol. The acidic nature of alcohol is due to the polar nature of the OH bond. When an electron withdrawing group, that is minus I group such as chloride and fluoride, etc. are attached to the carbon bearing OH group, it withdraws the electron density towards itself and thereby facilitating the proton donation. In contrast, the electron releasing group such as alkyl group increases the electron density on oxygen and decreases the polar nature of OH bond. Hence, it results in the decrease in acidity. So, on moving from primary to secondary and secondary to tertiary alcohol, the number of alkyl groups which is attached to the carbon bearing OH group is increases, which results the following order of acidity. That is, primary alcohol is more acidic, then tertiary alcohol, and then secondary alcohol, and then tertiary alcohol. For example, CH3CH2OH. The Ka value is 1.3 into 10 power minus 16. That is primary alcohol. And secondary alcohol, CH3CH3CHOH. Its Ka value is 3.2 into 10 power minus 17. Tertiary alcohol, CH3 thrice CHCOH. That is not CHOH. That is COH. The Ka value is 1 into 10 power minus 18. Alcohols can also act as a Bronston bases. It is due to the presence of unshared electron pair on oxygen, which makes them the proton acceptor. That electron transfer is given in this tabular column. Next, we are going to see the phenol, acidity of phenol. Phenol is nothing but an aromatic alcohol which is having a benzene ring with one OH group as a substituent. Phenol is more acidic than aliphatic alcohol. Unlike alcohols, it reacts with bases like sodium hydroxide to form sodium phenoxide. This explains the acidic behavior of phenol. Let us consider the aqueous solution of phenol in which the following equilibrium exists. That is C6H5OH phenol plus HOH, that is water. It is in equilibrium with C6H5O minus phenoxide ion plus H3O plus hydronium ion. The Ka value for this equilibrium is 1 into 10 power minus 10 at 25 degrees centigrade. This Ka value indicates that it is more acidic than the aliphatic alcohols. The increased acidic behavior can be explained the basis of the stability of phenoxide ion. We have already learned those things in our 11th standard. In substituted phenols, the electron withdrawing group such as NO2 and Cl that enhances the acidic nature of phenol especially when they are present at ortho and para position. In such cases, there is a possibility for the extended delocalization of negative charge of the phenoxide ion. On the other hand, the alkyl substituted phenols show a decreased acidity due to the electron releasing, that is plus psi effect of the alkyl group. And here in this tabular column, some of the compounds names are given and its pKa value is also given there. Okay, we can compare the acidity. Next, we will pass on the phenol. Phenol, already told you, this is an aromatic alcohol. Phenols are the organic compounds in which a OH group is directly attached to the benzene ring. The carbon-bearing hydroxyl group is sp2 hybridized. And the classification, this is also like the same: monohydric alcohol, monohydric phenol, dihydric phenol, and trihydric phenol, and then you have the substituted phenol. Monohydric means which is having only one hydroxyl group. If it is having only one hydroxyl group alone, it is called as phenol. And in the ortho position, if you have the CH2, that is called as orthocresol. If the CH3 is in para position, it is called the metacresol, and it is in the para position, it is called as paracresol. Dihydric alcohols, those two hydroxyl group are in the next one, consecutive one, that is called as 1,2-dihydroxybenzene or catechol, and next 1,3 position, this is called as resorcinol or 1,3-dihydroxy, and if it is in the para position, that is called as 1,4-dihydroxybenzene or phenol. And a trihydroxy also like the same. If it is in 1 to 3, that is called the pyrogallal. If it is 1 to 4 position, that is called hydroxyquinone. If it is in 1, 3, 5 position, that is called as fluoroglucinol. Substituted phenols, it is also, if depends upon the substituent, we can give the name as orthoaminophenol. NH2 group is attached. If a CHO is there, that is called as orthohydroxybenzaldehyde. If a COOH is there, that is called as para-hydroxybenzoic acid. Suppose if we have the two hydroxy group in the different position as well as the methane, then we can give the name or arsenal, otherwise it is called as 3,5-dihydroxytoluene. Toluene means which is having the CH group in as a substituent. Okay, now we are going to pass on the next one, that is preparation of phenols. From haloarenes, first process is Dow's process. When chlorobenzene is hydrolyzed with 6 to 8% of sodium hydroxide at 300 bar, that means atmosphere, and 633 Kelvin in a closed vessel, sodium phenoxide is formed, which on treatment with dilute HCl gives phenol. The equation is given here. Next is from benzene sulfonic acid. Sulfonic acid means SO3H is as a substituent in one position, and the benzene is sulfonated with oleum, and the benzene sulfonic acid so formed, if it is treated with NaOH at 623 Kelvin, we will get sodium phenoxide the first, and on acidification means treatment with hydrochloric acid, we will get the phenol. That equation is given under it. Next is from aniline. Aniline is nothing but the substituent is NH2. Aniline is diazoticized with nitrous acid, that is NaNO2 plus HCl at 273 to 278 Kelvin to give benzene diazonium chloride, that is benzene ring with N2Cl, which on further treatment with hot water in the presence of mineral acid like HCl, then you will get the phenol, nitrogen and HCl. That only given under it. Next is from cumene. This is one of the important reaction. A mixture of benzene and propene. Propene means which is having 3 carbon with a double bond, is heated with 523 Kelvin in a closed vessel in the presence of H3PO4, that is phosphoric acid as a catalyst. It gives cumene, that is isopropyl benzene. On passing air to the mixture of cumene and 5% aqueous solution of sodium carbonate, cumene hydroperoxide is formed by oxidation, it is treated with dilute acid, we will get phenol as well as acetone. And here we are getting the acetone. It is one of the important byproduct in this reaction. That equation is given here. First, benzene, if it is treated with the propane, it is substituted in one position of the benzene ring, that is called cumene. Again, if it is treated with air and sodium carbonate, you will get hydroperoxide. Then sulfuric acid, we will get the phenol. Next is the physical properties. Phenol is a colorless needle-shaped crystal, hygroscopic, corrosive as well as poisonous. It turns pink on exposure to light and air. The simplest phenol are liquids with low melting point, or otherwise they are having the low melting solids. They have quite high boiling points. Phenol is slightly soluble in water because of hydrogen bonding. However, the other substituted phenols are essentially insoluble in water. Then chemical properties. In chemical properties, it is under two categories depending upon the OH group and then depending upon the benzene structure. First, it depends on the OH group, reaction involving OH group. First, it is reacted with zinc dust. Phenol is converted to benzene on heating with zinc dust. In this reaction, the hydroxyl group, which is attached to the aromatic ring, is eliminated. That is, phenol treated with Z10, then O is removed and we get the Z10O zinc oxide as a product and benzene. Next, reaction with ammonia. Phenol is heated with ammonia in the presence of anhydrous zinc chloride. We will get aniline. Aniline nothing but NH2 is the substituent. Next is formation of esters. That is also called as a Scott-Bowman reaction. All the naming reactions are very important. So listen it carefully. Phenol on treatment with acid chlorides gives esters. Esters means which is having the functional group COO. The acetylation and benzonation of phenol are called Scott-Bowman reaction. That is C6H5OH, which is treated with CH3COCl. One of the hydrogen group from phenol and Cl element, both of them are removed as HCl and you will get CH3COO C6H5. Like the same, the phenol is treated with benzyl chloride. Again, the same H and Cl are removed from the compounds and we will get C6H5COO C6H5. Next is the formation of ethers. This is also called as Williamson synthesis. An alkaline solution of phenol reacts with alkyl halide to form phenyl ethers. The alkyl halide undergoes nucleophilic substituted by the phenoxide ion in the presence of alkali. Alkali is nothing but sodium hydroxide. See, phenol, if it is treated with sodium hydroxide, first the H is removed and Na is substituted there, that is called sodium phenoxide. And again, if it is treated with ethyl iodide, the Na group is removed and CH3 is substituted there, that is called anisole. Next is oxidation. Phenol undergoes oxidation with air or acidic potassium dichromate with the concentrated sulfuric acid to form 1,4-benzoquinone. And that reaction only given under it. Next is reduction. Reduction, you know, addition of hydrogen. Phenol on catalytic hydrogenation gives a cyclohexanol. If it is treated with hydrogen in the presence of nickel, those double bonds are removed and in that base hydrogen is added. So we will get cyclohexanol. Then reaction based on the benzene ring. Electrophilic aromatic substitution. In 11th standard itself we studied OH group and NH2 group are which directly attached to the benzene ring activate the ring towards the electrophilic substitution. And direct incoming electrophile to occupy the either the ortho position or the para position. That is common electrophilic aromatic substitution reactions are nitrosation. That is, phenol can be readily nitrosated at low temperature with HNO2, that is nitrous acid. So you will get OH and in the ortho position NO is added, that is called as para-nitrosophenol. Next reaction is nitration. Nitration, as I have already told you, it is a phenol is treated with a nitrating mixture. That is nothing but nitric acid and sulfuric acid. If it is treated with the 298 Kelvin, you will get the para-nitrophenol as well as ortho-nitrophenol. You will get the mixture of both the compounds. Here, the ortho and the para isomers are separated by steam distillation, as ortho-nitrophenol is slightly soluble in water and more volatile due to the intramolecular hydrogen bonding, whereas para-nitrophenol is more stable in water and less volatile due to the intermolecular hydrogen bonding. Next is nitration with nitric acid and sulfuric acid. At 298 Kelvin, it gives 2,4,6 trinitrophenol. This is also called as picric acid. The next reaction is sulfonation. Phenol reacts with the concentrated sulfuric acid at 280 Kelvin to form orthophenol sulfonic acid as the major product. When the reaction is carried out at 373 Kelvin, the major product is paraphenol sulfuric acid. Okay, that reaction only given here. Next, we will pass on the other reaction that is called as halogenation. That is addition of halogens. Phenol reacts with the bromine water to give a white precipitate, and that white precipitate is nothing but 2,4,6 dibromophenol. That is in the second position, fourth position, and the sixth position. Bromine at the bromine elements are substituted there. If the reaction is carried out in carbon disulfide or carbon tetrachloride at 278 Kelvin, a mixture of ortho and para-bromophenols are formed. That is, if it is treated with bromine water and CCl4, you will get OH and Br in the ortho position and Br in the para position. Next is Goldsmith reaction, or it is also called as Goldsmith reaction. In this reaction, phenol is first converted into sodium phenoxide, which is more reactive than phenol towards the electrophilic substitution with the carbon dioxide. Treatment with the sodium phenoxide with the carbon dioxide at 400 Kelvin in the atmospheric pressure 4 to 7 bar pressure, followed by acid hydrolysis, it gives salicylic acid. It is one of the important reaction. Phenol on treatment with NaOH, H is removed and Na is substituted in that place. And again, if it is treated with the carbon dioxide, in ortho position, you are getting COONA, that is called as sodium salicylate. If it undergoes hydrolysis with an acid, you will get OH and COOH in the ortho position, that is called as salicylic acid. Next is Riemann-Tiemann reaction. This is also one of the important reaction on treatment with phenol with the chloroform or sodium and sodium hydroxide. Aldehyde group is introduced in the ortho position. This reaction proceeds through a formation of a substituted benzyl chloride as an intermediate. This is CHCl3 with NaOH. If it is added, you will get the CHO group in the ortho position, that is called as salicylic aldehyde. Next is phthalate fusion reaction. On heating phenol with the phthalic anhydride in the presence of sulfuric acid, phenolphthalein is obtained. Phenol with the phthalic anhydride, you will get a three-membered ring, that is called phenolphthalein. This only we are using in the as an indicator in the acid base. Next is coupling reaction. Phenol couples with benzene diazonium chloride in an alkaline solution to form para-hydroxyazobenzene. That is also called as a red, that is also used as a red-orange dye. Benzene diazonium chloride with phenol. If it is treated, the chloride is removed with a HCl, then you will get 2 benzene ring and in intermediate is N2. So you will get para-hydroxyazobenzene. Next is the test to differentiate alcohols and phenols. As we have previously studied, with benzene diazonium chloride, phenol gives the red-orange dye, but ethanol have no reaction with it. And the next reaction is phenol gives purple coloration with neutral ferric chloride, but alcohols do not give such coloration with ferric chloride. Next one is a phenol reacts with sodium hydroxide to give sodium phenoxide. Ethyl alcohol do not react with sodium hydroxide. These three tests are to differentiate the alcohol and phenol. Next is uses of phenol. About half of the world production of phenol used for making phenol formaldehyde resin. That is nothing but bakelite. That is used to prepare the cooker handles. It is one type of plastic. Next is phenol is used as a starting material for the preparation of drugs such as phenacetin, salal, and aspirin. Phenolphthalein, we previously studied the reaction, the phthalate fusion reaction. There you got the phenolphthalein that is used as an indicator, and it is used as an explosive, and the explosive is nothing but the picric acid. It is also used as an antiseptic carbolic lotion and carbolic soaps. Next we have the evaluate yourself. You can try this one, and if you are not getting the answer, you will come and get the clarification in the doubt clearing class. Okay, now we will pass on another one, that is nothing but ethers. Ethers are a class of organic compounds in which an oxygen atom is connected to two alkyl or two aryl group, or it may be one alkyl, another one aryl. Ethers can be considered as the derivatives of hydrocarbon in which one hydrogen atom is replaced by an alkoxy group, that is OR, or an aryl oxy group, that is OR group. The general formula for the aliphatic ether is CnH2n plus 2O. Then classification. Ethers are classified into two, that is simple ethers and mixed ether. Simple ethers means both the alkyl or the aryl group attached to the carbon atom are the same. And mixed ether, two alkyl or two aryl group attached to the oxygen atom are different. That is called mixed ether. And aliphatic ether, two alkyl groups are attached to the ethereal oxygen, that is O, CH3, CH3. On both the ends you have CH3, CH3. So this is called as simple ether. And the next one is in the same aliphatic ether, one side the oxygen, on one side it is having CH3, and in other side you have CH, CH3, CH3. So both the alkyl groups are different. So it comes under mixed ether as an example. Next, aromatic ether. On both the sides benzene ring that is linked by the oxygen atom, that is called as phenoxybenzene. And next is methoxybenzene. One is the aromatic ring, another one is a CH3 alkyl group. So one alkyl group is attached with the aryl group with the oxygen. So it comes under mixed ethers. Okay. Next we are going to see the structure of the functional group. The structure of ethereal oxygen which is attached to the two alkyl group is similar to the structure of OH group of alcohol. Here the oxygen atom is sp3 hybridized. Two sp3 hybridized orbitals of oxygen linearly overlap with two sp3 hybrid orbitals of carbon which are directly attached to the oxygen, forming 2CO sigma bond. The COC bond angle is slightly greater than the tetrahedral bond angle due to the repulsive interaction between the two bulkier group as the alkyl group. Then IUPAC. IUPAC is, if it is given two methyl group are in both the sides, that is called as methoxymethane. Meth, then oxygen and methane. So methoxymethane. Next is one side you have meth, another one side you have the propane. So it is called as 2-methoxypropane. And like the same, the next is 2-methyl propane. And if it is the aromatic, we have the methyl phenyl ether, that is also called as anisole, methoxybenzene. And here the ethyl phenyl ether is there, that is also called as phenol. That is one side you have the ether group, one side you have the ethane, and another one you have the benzene, that is called as ethoxybenzene. If both the sides you have the benzene, you will get the name as phenoxybenzene. Like the same here, some more are given, and in this one you have the evaluate yourself, and you have to find out the IUPAC name as well as the common name for all those things, and write it in your assignment notebook. If there is any correction, you will get the clarification in our doubt clearing class. Okay, now we are going to see the next. You have the preparation of ethers, and this preparation of ethers we will go, and in our Zoom class we are going to see about those things. Okay. Okay, children, along with this I gave you the I am giving you the question. I am giving you the question and answer in the form of the PDF, and you have to write those things in your question and answer in your classwork notebook. Okay, we have a separate notebook for the chemistry alone, and in that one you are going to write the question answer, not the one more question, the question and answer, followed by this the assignment I am giving you, and that you have to do it in your notebook. Okay. Okay, children, read that lesson and write those equations in your notebook, chemistry notebook, and whenever we are asking you, you have to submit the notebook to us. Okay, ma? Thank you, children.